So welcome. Welcome back to this. So here we're doing a typical problem where we have a smooth table, no frictional force. We have a block connected using a piece of string to a load, and we want to do some analysis on it. Well, to do a proper question, we actually have to have some numbers. So let's imagine that we have a 8 kilogram block, and we have let's make it a 5 kilogram load. And somewhere, I got to say, it's a smooth table or frictionless. You got to somehow get that across to you. It's a level table, and there's two possible questions I can ask you. I could ask you what the acceleration, well, there's two types of question. I could ask you what the acceleration of the 5 kilogram mass is. I could ask you for the acceleration of the 8 kilogram mass. I could ask you what the acceleration of the system is. It's all the same answer. And then the next one is a little bit just that next step along, which is what's the tension once you've released this object. Before I release it, if I put my finger on that 8 kilogram block, then I can find my tension by saying there's no acceleration. So say for this 5 kilogram block, then positive T plus negative weight equals 0, so the tension must equal the negative weight, which is 50 newtons. And if the tension there is 50 newtons, then the tension there is 50 newtons, etc. But we're actually going to let this thing go, so it accelerates. And so the tension is going to be less. I'm going to show you how to do the tension, because that involves the first part as well. So, in the way I do it, there's a couple of ways of doing these, but first problem. Sign convention. This is really confusing because I have an up and down bit and a left and a right bit. So the first thing is you stretch this thing out so it's only in one line. Remember, you use these equations in a line. Piece of string is kind of magical. It enables a force to go around a corner. There's not really many things that do that. So let's just straighten out that corner. And I know that that's 50 newtons. And I know that that's the tension, and I know that that's the tension. I want to find T. I can pick either one of them. Let's say find T using the sum of the forces on the 8 kilogram is equal to the mass of the 8 kilogram times the acceleration of the 8 kilogram. That's just my shorthand. So I'm going to say, well, plus T, there's nothing pointing the other way, is equal to 8 times A. Oh man, if only I knew the acceleration. Find A using the sum of the forces on the system is equal to the mass of the system times the acceleration of the system. And when I say system, I mean that's my system. So I would say, okay, plus 50. There's no force pulling back on the system. The T's are inside, so they're not external forces to the system, is equal to the mass. Well, the mass of the system is 5 plus 8 times the acceleration of the system. So my A system is equal to plus 50 over 13. Now, if you're going to work out numbers early, you've got to give lots of decimal places. So 50 divided by 13 is going to equal, I can't just put down 3.3, I can't put down 4, and I really want 3.846, so else I get rounding issues. So get used to just giving me, you know, 4 sig dits is a good way to go. Now, is the thing, from a conceptual point of view, the acceleration of the system is the same as the acceleration of the 5 kilogram mass, which is the same as the acceleration of the 8 kilogram mass. So I can say, oh yeah, A system is equal to the A of the 8, which equals the A of the 5. They're all the same. This is the A of the 8 here. So my tension is equal to 8 times 3.846. So times that by 8. And I'm getting 30.77. So there we have it. It's not bad. You've got to straighten things out. You've got to make sure you have your forces, and you've got to know that the acceleration of all the bits are the same as the acceleration of the system. You could do this by saying the sum of the forces on the 8 equals ma, and the sum of the forces on the 5 equals ma, and then solving for a to get, you know, to get rid of it, substituting in for a, and that would also work. I like to do it this way because, frankly, if I ask you for the acceleration, you just do the middle bit. You know, it does not matter if you did the sum of the forces on the 5 equals the mass of the 5 times the acceleration of the 5. It would be the same answer. Maybe we should just, as a check, this is not required for the question, but as a check, let's do that. So let's put this down as check. And we can say the sum of the forces on the 5 equals the mass of the 5 times the acceleration of the 5. So we can say, looking at my 5, it's plus 50 added to minus t is equal to 5 times a, which gives me t is equal to 50 minus 5a. T is equal to 50 minus 5 times 3.846. So T equals 50 minus parentheses 5 times 3.846, close parentheses, equals, I'm getting 30.77. So same answer. It should be the same answer. Problem is, if you make a mistake on A, the fact that you get the same answer is irrelevant because you got the mistake on A. But it's kind of comforting that you get the same answer. From our perspective, it doesn't matter if I use the 5 as my starting point or the 8 as my starting point. Just got to pick one. So that's the basic idea. I want to do another one without friction. So just bear with me, okay? Everybody up to speed on that? So I should have put no, it's there, isn't it? It's not in the insert. Let's go slideshow there. Okay. Oh, sorry. Let's say that this is 3 kilograms and this is 7 kilograms. Let's say our table is at 30 degrees. Smooth table, smooth, no friction, but at 30 degrees. So the first thing I've got to do is I've got to turn around and say, okay, well, let's draw a stretch diagram. What will this force here be? What's this numerical value? You look over to your diagram and you see what that force is. Force is there. And what is that force? What is it? 70 newtons, yeah. So that's 70. Now, I'm going to change coloured pens because I've got to do a bit of thinking here. I got 30 newtons there, and I got Fn there. I don't care about the Fn because it's perpendicular to my direction of motion. But that 30 does have a component. If I resolve that 30 in that direction, this is going to be, oh man, I used 30. It's going to be 30 sine 30. I try not to use the same number twice. So let's just draw that out big. That's 30. If that's 30, that's 60. If that's 60, that's 30. This is 30 sine 30. It's also 30 cosine 60. Same thing. Yeah? So here, I'm going to put down 30 sine 30. Find t. Find t using the sum of the forces is equal to ma. Well, might as well, let's pick the 7. The sum of the force on the 7 is equal to the mass of the 7 times the acceleration of the 7. So I go plus 70 added to minus t is equal to that mass, which is 7 times a. So my tension is equal to 70 minus 7a. pulling a new A. Find A using the sum of the forces on the system is equal to the mass of the system times the acceleration of the system. So now I'm looking at my system, of course, is that entire combination. It's like a train with carriages. So I say plus 70 added to minus 30 sine 30 is equal to 7 plus 3 times A. I like to put 7 plus 3 down rather than 10 so that I remind myself that I did actually add the two together. If I just do it in my head, I might not spot it when I check my answer. So A is equal to 70 minus 30 sine 30 over, now I'll add them together, 10. So A is equal to, I get my calculator, and I go 70 minus parentheses 30 sine 30 close parentheses equals, and then divided by 10 equals 5.5 meters per second squared. So T is equal to 70 minus 7A, which equals 70 minus 7 times 5.5. T is equal to 70 minus parentheses 7 times 5.5 parentheses equals 31.5. So, same pattern. All that's changing is we have components this time. And again, components are not the issue anymore. Components are just like dividing, like squaring something. They're a skill, they're a background skill now. So adding them or taking them away, it's not what the question's about. From the physics point of view, a component's just a component. But it does make it a more involved question. What's the biggest acceleration that my system can have? If I increase that 7 to 5,672, so it's a massive, massive load, a huge weight. What's the maximum acceleration that that system can have? Yeah, 10. Because that's free fall. Imagine if there was no 3 kilogram, it would accelerate downwards at 10. The 3 is not going to slow it down by much. So we tend to go from an acceleration of 0, I suppose, at one extreme, up to an acceleration of 10. So if you're getting an acceleration that's bigger than 10, there's a problem somewhere, because you're going big, faster than free fall. You got some sign that's wrong somewhere. Cool, okay. Let's try now one with a bit of friction in. Oh, sorry, was there any questions? I just blew on. I tend to blow on. No questions? Let's do one of these with free fall. These masses are free to move, 2 and 8. There is a 0.2 coefficient of friction between the block and the table. What is the tension when the system is released? Wow. I'm glad I'm not in my office. I will be in a little while. There's 42 pylons they've got to plant. And we're going to get this like 42 times. So, first of all, we're going to do our stretch diagram. It's find T. And this, of course, down here is 80. And that's T. And that's T. And I do have an FF in this case. There's 80. There's my backwards facing T, and there's my pull along T. And I need a numerical value for that FF. You can do it here, or you can do it down here. FF is equal to mu K times Fn. FF is equal to 0.2, and Fn is 20. And I can do that by saying that's 20, and that's Fn. FF is equal to 4 newtons. So I'll do a little aside calculation. And now it's same old, same old. This is 8, and this is 2. I say find T using the sum of the forces on the 8 is equal to the mass of the 8 times the acceleration of the 8 plus 8t added to minus t is equal to 8 times a. T is equal to 8t minus 8a. Oh, if only I knew the acceleration. Find acceleration using the sum of the forces on the system equals the mass of the system times the acceleration of the system. Look at your diagram. Plus 8t added to minus 4, not going to make much difference, is equal to 8 plus 2, there's your two masses times A. A is equal to 80 minus 4 over 10, which equals 7.6 meters per second squared. So, T is equal to 80 minus 8 times 7.6, which equals 80 minus bracket 8 times 7.6, 19.2. So, you know, the only wrinkle to this one is I had to figure out what my frictional force was. But the rest of the problem was the same. Yeah? I've got 7 minutes. Let's do the last one. A 3 kilogram block has an acceleration of 1.5 meters per second squared, pointing down the slope. There's a bit of language issue there. What is the coefficient of friction? my acceleration is 1.5 meters per second pointing down the slope. What's the coefficient of friction? Find mu k using FF is equal to mu k times Fn. Okay. Mu k is equal to FF over Fn. Okay. Find FF using, I don't want Fn. I'm going to change colored pens. The sum of the forces on the red line equals MA. Here's a tip. Whenever you have a net acceleration, go in that direction to begin with. That's another way of doing this as well. It's going to be the same thing. It's another justification for doing it this way. You're going to say, well, that as a component. This here is 30 sine 20. That's 20 degrees. This here is FF. I go FF plus minus 30 sine 20 is equal to 3 times, I know A. A is minus 1.5. And there's the catch. I don't say it's minus 1.5. I say it's 1.5. But it's pointing down the slope. You just decided that that was a positive direction because you had a positive FF, and you decided that was the negative direction because you have minus 30 sine 20. So that means the acceleration must be negative, and there's the mistake that most people will, if they're going to make a mistake, they'll fall into that mistake. So FF is equal to 4.5 minus 4.5 plus 30 sine 20. FF is equal to, on clear, 4.5, let's do it the other way around, 30 sine 20, enter. That's 10 point something minus 4.5 equals 5.76. Change colour pens. Find Fn using the sum of the forces along the green line equal, don't want to deal with FF, I'm going to do my green line. Am I accelerating along that green line? No. Is there any component of my acceleration along that green line? No. Because at 90 degrees to it. So I have no acceleration. Oh, equals 0. Not MA. So I look along here and I go FF. Oh man. No, sorry. I look along here and I go Fn. And I look down here and I go 30 cosine 20. And I go plus Fn added to minus 30 cosine 20 equals 0. So Fn is equal to 30 cosine 20, Fn is equal to 30 cosine 20 is equal to 28.19. So mu k is equal to 5.76 over 28.19, which equals 0.2. Same skill, just put in different package, aren't they? You got to draw a good diagram. You got to know the equation. You got to know what directions to resolve your forces in, so efficiently get the answers. It's just the same skills. Just can you see how the content's not increasing, but the skills are? Okay. We've got a little bit on apparent weight, which I'll get to next time.